So I'm director of LTRI, and we specialise in creating hybrid technologies for the creative industries. I'm really interested in this idea that art is fundamentally concerned with the co-constructed design of experience. So I'm looking at how we can use technology to enable experience communication rather than what we've all been used to, which is information communication. I'm interested in, again, augmented reality is a bit hit and miss, to say the least, so I'm really interested in sensory augmentation and not focusing so much on the technology but on our actual bodies and the way we perceive. A good example of that is this guy Neil Harbison, who was colourblind. He's basically come up with this, you know, we're all creating apps for everything, but actually we should be creating applications for our own bodies. And his particular application, you can sort of see it on his head there, it's a bit dark, but it's he's colourblind, and what he's done is he's created a device, a simple prosthetic, which transforms light waves into sound waves using a webcam, computer and a pair of headphones, very cheaply. And effectively, this brain hack was quite tricky to start with. It took about 5 weeks for his brain to adapt. But now he can effectively see, and he can hear colour. So he's changing the way he perceives art, and he's created a completely new world. So he's currently working on seeing ultraviolet. He can see about 360 colours at the moment, very accurately, through hearing. So it's a very fascinating brain hack. We've got things like this, which is a belt that allows you to feel magnetic north over a period of weeks, and once you take it off, you have that as a new sense. That's called feel space. I've mentioned this before, but this is a headset we're testing in our lab at the moment, and it's got a 360 camera on the top, which is then squashed into a 180-degree visor at the front. Your normal vision is 180 degrees. It takes the brain only 15 minutes to adjust to seeing in 360, and it's almost as if the brain's been waiting for that hack. So it's a case of just imagine if everyone could see around them all the time, what would it mean? Obviously things like safety on the roads. Think about all the new sports that you could create and all the new kinds of art that you could create with that technology. And this is something else that's relating to this idea of engineering the senses rather than the content. So I'm really interested in, you think about it, like content augmentation is what we've been doing throughout history, but now it's time to actually augment the context, the way we perceive that content. So for instance here you've got a lab in Japan which is increasing the size of your food whilst you eat it in order to allow your brain to feel as if you're eating more. So you lose weight. Somebody pointed out to me that this would be really good for people with anorexia to make their food seem bigger than it is, so they can eat well. Sorry, the other way around. You know what I mean. This is another example. Another example of context engineering. Digital music is cheap these days. We throw it away. We don't really listen to it. This forces you into a context where you have to really be listening by being still. So you don't get to hear the music until your body is still. Or the other example where you have to dance all the time in order to hear the music. So again, changing the context. Or this example, IDAS Outcomes at Royal College of Art, and they've created two prosthetics. One that I'm focusing on here, which is to actually slow time down in real time visually, so you can start to see patterns forming in space. So again, it's their philosophy as well. What if we had the same control over our senses as we have over content, and adjust our senses in real time? So this artist actually sums up that point. So we're reimagining what already exists. We're recycling and using perspective to shape reality instead of changing reality itself. A good friend of mine, Adrian Chook, who's professor of persuasive computing over at City University, he's creating the multisensory internet by allowing you to taste the internet, taste objects from the internet through your mobile device. Very strange technologies. He's also got a smelling a device that pumps out smells from your mobile as well. He's got a kissing device, which again is very odd down here. So you can do remote kissing and remote hugging. This is remote rings for couples. One of the things that's I'm not really talking about challenges here, but one of the challenges in this sort of stuff is that I was at one of his lectures and somebody asked, well, this allows you to, he's talking about remote communication and to stay in touch with people, but one person pointed out that actually that means that you're encouraged to be remote. These technologies are encouraging remoteness, whereas actually we want proximity. Another example, which is the Oculus Rift headset combined with body sensors, which is doing this sort of thing. So on here you've got the sensors on the body, he's wearing the Oculus, so he's completely submerged in the 3D world. So again, what does it mean? Yesterday somebody came out with this brilliant point. They said that they didn't really understand Jackson Pollock until they understood that he was listening to jazz as he was creating his paintings. And just this augmentation of enriching the content with the context that he was actually in whilst he's making the art transformed her understanding of the art. So if you think about museum annotations, how can we start to make them a little bit more intelligent? How can we start to do things rather than distract people with constant digital annotations? How can we start to make things more contextual rather than content-based? And as McLuhan says, we shape our tools and thereafter they shape us. A brilliant example of this is 3D movie. Hugo, this neuroscientist, Bruce McNaughton, was sitting in the cinema having only really experienced 2D, variations on 2D reality up until he watched that 3D film, and then his whole visual cortex clicked into place and he suddenly started to see in 3D. So incredible technologies that can do amazing things. But there are challenges, massive challenges for all of this sort of stuff. This is Stop the Cyborgs group, who are really concerned with the ethics of always being on, always being connected and augmented. And things like Google Glass, which is getting a really hard time, I think, and it hopefully will fail abysmally. But what we're seeing, I mean, it's going to have uses in certain use cases, but not socially. I would hope not anyway. But it's this idea that we're going to lose common ground. Everyone's going to be personalising their own view onto the world, and there's loads of problems with it. Also, things like Google have started. This is the next level of human-computer interaction. They're patenting, positions on this. This is owned by Google. And it's in combination with Google Glass. So if you do this shape in front of Google Glass, it will trigger an activity or trigger some. But this is actually, amazingly, the American government have patented that. They won't allow it in Europe, but in America they allow it. And Stellark, who's done a lot of body augmentations, he's actually starting to question whether the body is well equipped, considering we've got such low, in terms of the brain filter, we take in millions of bits of information, but we can only process something like 40K. So is the body equipped for all this stuff? I would argue for some of it is. Like for instance, the 360 helmet, it's only 15 minutes and then so it's a lot of research. And we've also got this sort of thing coming through where your brain apparently no longer knows the difference between emoticons and emotion. So we've got huge things going on in the brain that the neuroplasticity is something that's, again, massively important for research. I would advise you not to look at this for very long because it's called the McCulloch effect. And again, this is just my last little video.
Literature called harmful sensation. There is an idea in literature called harmful sensation. The idea that a sight, a pernicious idea, a sound, a song, can get into your head and stay there for a very long time and actually do you harm. Pernicious earworms aside, there is actually a real thing that can get inside your head and affect the way your brain works just by looking at it. It's called the McCulloch effect, and just a warning, I realise that telling people on the internet not to do something is like telling a 5-year-old not to stick beans up their nose. They are trying to stick beans up their nose. But seriously, if you work with text or video, don't do this. The McCulloch effect revolves around these images. If you stare at them for long enough, we're talking sort of anything up from 15 seconds to 15 minutes, you'll get, as you would with, say, blank colours, the opposite appear in your brain. If you stare at a green light for long enough, you'll see red for a little while afterwards. But this doesn't work at the retinal level. The McCulloch effect, for some reason, works in the level of the brain. You induct these for long enough, for 15 minutes, you're going to see the inverse colours on those gratings anytime you look at something like, say, these railings, all the time, for anything up to 3 months. The McCulloch effect is a very rare thing. It's quite scary. It's a real image that can lock into your brain, change the way it works, and stick around for a good while.
So actually I'm work package 4 leader on the CRe-Am project, and one of my jobs, my main job, is actually to look at these technologies and to see which ones are actually producing weak signals. So we've got a lot of field of view technologies coming in, like the Oculus Rift, which works because it removes peripheral vision, and it's like a brain hack. Your consciousness thinks it's wherever you're looking at. So it's very immersive, but again, peripheral vision is very important for creativity. It's very important. It's a very important neurotransmitter. So it's, just to sum up, I'm really interested on this idea of focusing on feeling rather than actually just building more cognitive dissonance through cognitive overload, which is leading to a diminishment of reality. We've got to take advantage of the plasticity of the brain, the plasticity of the senses. We've got to learn more about human perception. I believe we can use technology to do that, and actually looking at crossing over the senses and seeing what we can do with that. The fundamental problem is always that we look at technologies and see things from a technological point of view and don't define the human need. And I think that context can be really interesting for actually looking at human needs. And I think there's a whole economy coming out of contextual augmentation rather than content augmentation, which we've done to death. So thank you very much.